Vitamin C. The chemical term is ascorbic acid, and it has a symmetrical 6 carbon atoms that is related to glucose, just as you can see in the picture. And then humans, we are unable to synthesize vitamin C because we lack the enzyme called gulonolactone oxidase that is needed for vitamin C biosynthesis. And this vitamin C was isolated in 1928 and its structure was determined in 1933. A glimpse of history of this vitamin C. So vitamin C, as I said a while ago, was isolated in 1928 and it was the structure was determined in 1933. This vitamin's deficiency disorder known as scurvy had been prevalent for centuries. And then some of the most notable stories are those of the British sailors who frequently died from scurvy on sea voyages. And it was a physician who eventually found that sucking the juice from a lime was protective. And in the late 1790s and early 1800s, British sailors at sea began receiving limes, and it results in the nickname limey for the sailors. Zent Georgi in 1928 and King in 1932 are considered co-discoverers of vitamin C. Dietary forms and vitamins. So we have here ascorbic acid, and it's dihydroascorbic acid, the oxidized form. So in physiological pH, this ascorbic acid loses hydrogen. And then if it loses a hydrogen, it then forms the ascorbyl radical. So kaning ascorbyl radical will undergo simultaneous oxidation and reduction to form then dihydroascorbic acid. So makita nato diri sa green highlighted part, ang duha ka oxygen sa dihydroascorbic acid kay wala na hydrogen. And we all know nga maabsorb lang sa human body kay ang ascorbic acid na form. So how can we convert this dihydroascorbic acid back to ascorbic acid? So we need the help of glutathione. So mangyayo tawag help dari sa reduced glutathione since naa siya hydrogen. And then through the help of glutathione and its reduced state, maka-form na din tabalik og ascorbic acid and ma-absorb na din siya sa human body. Sources. We all know that vitamin C's main sources are citrus fruits. So we have here tomato juice with vitamin C content of 170 mg, orange juice 124 mg, strawberries, papaya, orange 87 mg, and then kiwi 64 mg. And this next slide, the highest food nga contain og vitamin C is the orange juice, the kiwi, and strawberries. We have also here the cantaloupe. Digestion and absorption. So vitamin C does not require digestion prior to being absorbed into the intestinal cells. So because this is a water soluble, it can be easily excreted in the urine. So in this illustration, we have here the ASC abbreviation as ascorbic acid, the SVCT1 ASC again. So we have here the transporters, SVCT, the sodium-dependent vitamin C transporters. So across the intestinal brush border membrane occurs throughout the small intestine, especially in the proximal jejunum, and requires SVT is the absorption flow of vitamin C. So mao to kung giingon ganiha nga dili ma-absorb sa human body ang dihydroascorbic, since as you can see in this illustration, dapat good in the ascorbic acid form siya. So to enter the blood plasma, vitamin C appears to diffuse out of the intestinal cells into the extracellular fluid through volume-sensitive anion channels that create openings or pores in the basolateral membrane. So any dihydroascorbic acid that did not get converted to ascorbic acid within the entire site is thought to diffuse into the plasma. So this transporter, the SVCT1, is very important in the absorption process of the vitamin C. So this ascorbic acid, through the help of SVCT1, will enter the entire site up to the capillary. And in addition, absorption of the vitamin C decreases with increased intake. So if your intake is 12 grams, you have 16% chance to digest it. While in 20 milligrams, we have 98% to digest the vitamin C. So as you can see in the illustration, we have here the ascorbic acid form that needs the sodium-dependent transporter and then enter the cell as ascorbic acid form. And the oxidized form, the dihydroascorbic acid, will need a glucose transporter and then undergo reduction so that it can enter the cell as ascorbic acid. So transport. So ascorbic acid and dihydroascorbic acid are transported in the blood primarily in free forms. However, only very small amounts of dihydroascorbic acid are present due to its rapid cellular uptake. So nag-ingon ako kaganiha nga kaning dihydroascorbic nga dili ma-convert to ascorbic acid kay dili na siya makasulod sa cell. So dito na siya ma-diffuse sa plasma. So the transporters are the following: the sodium-dependent vitamin C transport, SVCTs 1 and 2, and the glucose transport, GLUT1 and 3. Tissue uptake. Ascorbic acid uptake into body cells occurs by SVCT1, which exhibits a relatively high capacity but low affinity. So unsay pasabot na yung high capacity but low affinity? So dako ang capacity ni SVCT1 nga masudlan og vitamin C. However, dili pud siya sa affinity mabikil kay low affinity man siya. So gamay ra ang iyang gaka-attract nga vitamin C bisag taas ang iyang capacity or dako iyang capacity. However, in the SVCT2, it displays low capacity but high affinity. So gamay ra ang iyang capacity nga makasulod ang mga vitamin C. However, strong ang iyang affinity to attract vitamin C. So no, dari nga part kay ang SVCT1 and SVCT2 kay very opposite. So SVCT1 is found primarily in the intestine, liver, and kidneys. And the SVCT2 is present in most metabolically active tissues including in the brain, neurons, bone, and endocrine glands. So maunang there's a brain, neurons, bone, and endocrine glands. High concentration ni siya sa vitamin C for the reason that ang SVCT2 kay taas ang iyang affinity nga maka-attract og vitamin C. So tissue concentrations of vitamin C usually greatly exceed plasma concentrations. So mulapas daw ang concentrations of vitamin C sa tissue kumpara sa plasma. So for example, the vitamin C content of white blood cells, this is a tissue, can be as much as 80 times greater than plasma concentration. Storage. So high concentrations vitamin C are in the adrenal and pituitary glands, eyes, brain, white blood cells, and neurons. So na-transport ni sila through the SVCT2 nga high og affinity to attract vitamin C. Whereas in the intermediate concentrations includes the liver, spleen, heart, kidneys, lungs, pancreas, and muscles. So ma-transport po ni sila sa SVCT1 nga low og affinity to attract vitamin C. And the skeletal muscles in addition has about 1,000 to 1,500 milligram of vitamin C. So functions. Vitamin C is the main water-soluble antioxidant. It acts as an antioxidant against oxidative stress. So this oxidative stress is an imbalance between the amounts of reactive oxygen molecules and the availability of antioxidant defenses. So makita nato sa picture kaning yellow galing ang murag sun, mao ni ang free radicals. So unsa man po ning free radicals? So these free radicals molecules that are coming from the environmental sources such as air pollution or cigarette smoke that cause damage by snatching electrons from the DNA. So without vitamin C, these free radicals can damage DNA and other molecules. Whereas with ascorbic acid, ma-neutralize siya. So what does it mean nga ma-neutralize? So ang vitamin C mag-donate og electron to regenerate the active antioxidant form. So through the help of vitamin C, ma-neutralize ni ang free radical para dili na siya makadamage sa mga DNA. Vitamin C also function as a reducing agent to maintain the iron and copper atoms in the reduced state so they can be more absorbable. And then it also function in the immune system. It can shorten the duration of cold symptoms by about 8% in adults and 14% in children. So, ang vitamin C dili bot pasabot kay makaayo gid siya diretso sa sipon. Ma-shorten lang niya ang duration sa sipon. So other functions we have here for collagen synthesis. So we can see in this illustration that the collagen molecule with no vitamin C is weak, abnormal connective tissue. Whereas if naa siya vitamin C, kay kuan siya strong, healthy, and cross-linked connective tissue. So giunsa man ni vitamin C pag tarong sa mga collagen? Unsa man ang role ni vitamin C? So vitamin C is a coenzyme needed for the activity of the enzymes that add the hydroxyl groups to the amino acids proline and lysine to form hydroxyproline and hydroxylysine respectively. So these hydroxyl groups are necessary for the formation of chemical bonds that cross-link the polypeptide strands of collagen to give it strength. Vitamin C health consequences deficiency. So inadequate intake of vitamin C results in the deficiency condition called scurvy. So scurvy is manifested when the total body vitamin C pool falls below about 300 mg and plasma vitamin C concentrations drop to less than about 0.2 mg per deciliter. So scurvy is fatal and it is a serious disease if it is left untreated. So the 4H, we have here the hemorrhagic signs, the hyperkeratosis of hair follicles, the hypochondriasis, physiological manifestation, and hematologic abnormalities. These associates mainly with impaired collagen synthesis. These are often used as a mnemonic device for remembering scurvy signs. So scurvy in adults is treated with vitamin C in doses of about 300 to 1,000 mg daily until the symptoms are gone, which usually takes about 3 months. So health consequences if the vitamin C intake is excess. So we have here toxicity and supplements. So sa supplements ni siya nag-base. So ang 2 grams of vitamin C daily has no adverse health effects. But if mulapas na gani og 2 grams ang imong ginainom mga supplements sa vitamin C daily, magka-problem na siya sa gastrointestinal nga ga-characterized by abdominal pain and osmotic diarrhea, kidney stones or nephrolithiasis, iron toxicity for those with disorders of iron metabolism, and interfere with some clinical laboratory tests. So interactions with other nutrients, so vitamin C and iron. Vitamin C is thought to increase the intestinal absorption of non-heme iron by reducing ferric state to its ferrous state. The vitamin C and copper, vitamin C also increase absorption and excretion of heavy metals. Vitamin C intakes above 600 mg per day may interfere with copper metabolism. And then in vitamin C and folate, vitamin C helps keep folate in its reduced and active form. So excretion. So vitamin C is primarily excreted via the urine. So when the intake is low, gamay pod ang atong maihi. So unmetabolized ascorbic acid excreted also via the urine. So it can also be excreted intact or oxidized by L-ascorbate oxidase to oxalic acid, primarily in liver and some in kidney. So the recommended nutrient intake. So for adults, age 19 to 28, for males, we have recommended nutrient intake of 70 milligrams, while in female, we have 60 milligrams. For pregnant women, 60 milligrams plus 10, so it falls as 70 milligrams. And in lactating, 60 plus 35, so it falls at 95 milligrams. So upper tolerable limit for adults age 19 to 28, we have the UL of 1,000 milligram. For pregnant and lactating, the age of 14 to 18, we have 1,800 milligram. For over 19 years old, we have 2,000 milligram. International units represent the quantity of a nutrient that produces a particular biologic effect but do not account for differences in biological activities among related compounds. So 1 IU is equal to 50 micrograms of vitamin C. So to convert micrograms to milligrams, 1 micrograms is equal to 0.001 milligrams. So kung naatay 50 micrograms of vitamin C, since 1 IU is equal to 50 micrograms, makagain siya or makonvert na siya into 0.005 milligrams of vitamin C. So 50 micrograms of vitamin C is equal to 0.005 milligrams of vitamin C. I have read this a specific article that calls choline as the underappreciated vitamin. But let us appreciate choline in this point. So choline, the Greek term chole, was first isolated in the ox bile. This is a vitamin-like compound essential for humans to survive. So it can be synthesized in the human body, but the amounts are not that high enough to meet the needs. So this is an amino acid glycine that carry 3 metal groups, as you can see in the illustration. And it is the newest nutrient established known in literature as vitamin B4, part of neurotransmitter acetylcholine and component of phosphatidylcholine and sphingomyelin, the major phospholipids in the cell membranes. So sources. The best dietary sources of choline are egg yolks, liver, meat and fish, whole grains, and nuts. So as you can see in the illustration, eggs have the highest choline, followed by beef, chicken, pinto beans, salmon, and others. Digestion and absorption. So choline is actively taken by the enterocytes via the choline transporter-like protein, or the CTL. So in this illustration, the ingestion of phosphatidylcholine, or PC, which is the main storage form of choline in animal tissues, is later converted to choline by the enzyme phospholipases. So na-convert na ang PC pag enter niya sa enterocyte as choline. So makita na to ng blue arrow, no? So the water-soluble choline then enters the portal vein or the portal circulation unchanged. The absorbed choline passes in the liver and enters the systemic circulation. However, this transporter, the CTL, has limited ability to transport choline. Thus, at high concentration, part of it is left unabsorbed. The unabsorbed choline will be degraded to trimethylamine, which is oxidized in the liver as trimethylamine and oxide. So this PC has also other fate. It can enter the lymph or the lymphatic system, then incorporated to chylomicrons up to the adipose and the muscle. So no, kanina dere sa digestion and absorption, duha ang padulngan. So ang through the PC, ang main storage siya choline. Then, the help of the enzyme phospholipases, mag-enter siya sa enterocyte, then ma-convert siya into choline. Dayon, maagin din siya portal vein up to the liver and the systemic circulation in the body. Ang second po niya nga path, mag-enter siya sa lymphatic system, tas ma-incorporate na din siya as chylomicrons, then up to the adipose and to the muscle. So choline also has the mechanism of transport as carrier-mediated diffusion. Because as I said a while ago, charged cations do not readily cross cell membranes by passive diffusion. So magamit yun nato ang carrier-mediated diffusion. So nga naman, because this choline transporter-like protein kay responsible for the uptake of organic cations. So kani nga transporter no kay naa gyapon cations. So ma-utilize gyud ang carrier-mediated diffusion for the mechanism of transport. So transport and tissue uptake. So choline is transported to the tissues predominantly as phospholipids associated with the plasma proteins. So the choline transporter-like protein 1 has high affinity. So taas ang iyang chance nga mo-attract og choline, while the CTL2 or the choline transporter-like protein is low affinity. So mubo ra yang chance nga mo-attract og choline. So the greatest concentrations of choline, so magamit ni dari ang CTL1 since it has high affinity to attract choline. So high affinity means a great concentration. So we have here the brain, liver, and kidney. Then the acetylcholine, a neurotransmitter for brain function and memory, has large amounts in the placental tissues. So makita nato dari no sa picture nga sa CTL1 high affinity siya. So mag-enter din siya sa placenta, tas mag-produce siya og choline. Ang CTL2 sad mag-enter siya sa placenta, tas mag-produce din japon siya og choline. So this choline magkuan og acetylcholine, choline phospholipids, and betaine. So sa acetylcholine na siya neurogenesis, synapse formation, and placental development. Sa choline phospholipids siya sad membrane biogenesis, myelination, cell division, and lipid transport. Sa betaine, methyl group donation. So no, importante jud kayo ang choline during pregnancy for the normal brain development and memory function of the child. So storage, choline is stored in the cell membranes and organelles as phospholipids and inside cells as phosphatidylcholines and glycerophosphocholine. So functions. So choline functions to produce neurotransmitter acetylcholine for brain function memory. So choline is also oxidized to betaine. This betaine supports folate as an alternative methyl donor in one-carbon metabolism that plays a central role in cell metabolism and DNA methylation. And this S-adenosyl homocysteine is the biosynthetic precursor to homocysteine. So kaning S-adenosyl homocysteine, mahimo siya og homocysteine that is related to cardiovascular disease. Through the help of choline, homocysteine will then be converted to methionine because choline is a precursor of betaine which provides a methyl group for the conversion. So this methionine prevents the accumulation of fats in the arteries. Then this methionine will oxidize as S-adenosyl methionine that is important in control of DNA replication and cell growth. This cell growth affects the phosphatidyl ethanolamine that is the most abundant lipid on the protoplasmic leaflet of cellular membranes. Then the cellular membranes includes the component phosphatidylcholine that is important for liver and brain health. Health consequences. The deficiency and excess. So nag-mention ko kaganiha that CTL has limited ability to absorb choline. So the left unabsorbed will then be oxidized in the liver as trimethylamine N oxide or TMAO. So thus, if the TMAO is high, it can lead to cardiovascular impairment. So high intake of choline also has the chance to have a high unabsorbed choline. So this high unabsorbed can cause cardiovascular impairment. Meanwhile, the deficiency of choline includes non-alcoholic steatohepatitis, liver fibrosis, and inflammatory bowel disease. Interactions with other nutrients. This adenosylmethionine or SAM cycle are actively exchanging chemical components, especially chemical structures called methyl groups. And one of the choline's job is to keep methyl groups cycling around for eventual donation to S-adenosylmethionine. So methyl groups around SAM cycle is dependent on folic acid, which is particularly good in accepting methyl groups from other molecules. So due to this, folate deficiency is especially likely to disrupt the SAM cycle balance and in process, choline status as well. So makaapekto jud ang folate deficiency sa choline status. Excretion, we can excrete choline through the urine excretion, and doses of 2 to 8 grams can still excrete little choline in the urine. Excretion happens via transporters that occur within kidneys such as CTLs or choline transporter-like protein. Recommended nutrient intake. So for 19 plus years, 550 for males and 425 for females milligrams per day. And for the pregnant women, we have 450 milligram per day, and for lactating women, we have 550 milligram per day. In the upper tolerable limit, for adults 19 years and older, we have 3,500 milligram per day.